Hey everybody, welcome to the iPhreak Show. Today on our panel we have Michael Holt.
How's it going, everyone?
And this is Jaim Zuber. I'm calling in from Minneapolis, Minnesota. We have a guest today. Please welcome Paul Samuels.
Hey.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code devchat at Sentry.io to get 2 months free on Sentry's small plan. That's code devchat at Sentry.io.
So Paul, can you tell us a little bit about yourself?
Hey, so yeah, I'm a developer from Leeds in the UK. It's a bit of a time difference from you guys, but I've been doing iOS for around 9 years now. And I guess the kind of call to fame at the beginning of that is that I attended a course that was delivered by Dave Verwer. So it was a very intense 5-day course, but I came out of it at the end with my head throbbing. But yeah, it's kind of set me up for the next 9 years, really. So that's a little bit about me.
Okay, so you took a course with Dave and you came out an expert iOS programmer. That's pretty impressive.
Definitely not an expert at the end of it, but it definitely set me up.
But cool. We brought you on the show to talk about a blog post that you wrote about tying things together. Can you tell us a little bit about that?
Sure. So there's literally nothing new here. It's not a new idea, but it's essentially a blog post that kind of goes through the process of how you'd write some code that you could reuse across an iOS application, a website, and potentially a command line interface. It's looking at just how we would modularize code, and it really gives you quite a lot of kind of abilities for taking things to the next level. If you can get your code to run in all those different environments, then it really opens up a load of potential around all kinds of tooling that you can build. So that's kind of the post that I wrote, and it was really kind of tying together a few of my previous posts around reusing code from an iOS application in a command line interface, just the general idea of we should be writing command line interface tools if it kind of makes sense, because sometimes you don't want to go write a full blown app just to test something. And yeah, just there's been a bit of a theme going on. So in my last kind of few blog posts, and this is the one that kind of brought them all together, really.
Okay, that's pretty cool. So what are some of the takeaways from the blog post?
So I guess the takeaways that the kind of a lot of the kind of new trends about everyone seems to be doing a lot of modularization these days. Swift Package Manager came along that enables packaging your stuff up a bit better. And now that we've got kind of the ability to deploy to Linux, you can really, your code becomes a lot more portable, and you can start to realize some really cool tooling actually. So some kind of examples that come up with are the company where I've just left. They had a back-end team. So that was divorced from the client teams, and the back-end team had multiple kind of clients and stakeholders. So they didn't necessarily have a contract that we could always depend on. So what was really good is that we could write our kind of production code that we use within our iOS application. And we had the potential now to put that code inside a container and give it to that team so that they can now put that in their CI pipelines. And that just kind of gives you the ability to start to automate the whole process so that actually the kind of upstream team wouldn't be allowed to deploy changes that would break the client. And that's just one of the kind of many use cases that we didn't quite get there in that team because there wasn't necessarily enough buy-in from kind of management, but it's definitely would have been a really nice use case. And it was almost across the line. It just needed buy-in from the kind of upstream team to integrate those kind of components.
Okay, let's step back a little bit and talk about some of the terms that you threw out there that some of our readers may not be familiar with. So you're writing a client app, which is like an iOS app, Mac app, something like that. You talked about a contract. What is the contract?
Okay, so when we're getting data from our kind of backend CMS or data feed, the contract there would be that they kind of assure that they will return the data in a structure and a format that the client understands. So imagine they're returning JSON. The client app is going to expect certain keys to be present in the right places for it to actually be able to interpret that data. So the kind of issue is because these teams are separate, there's every chance that the backend team could make a change where they remove a key that the client depends on. And that just means that when we come to parse that JSON, we're no longer going to be able to understand it. If we've written our clients in a kind of resilient way, then we won't crash. We'll just kind of filter away that data. But those are the kind of issues that I think are probably slightly more dangerous for us, because if you get a crash and you've got some kind of crash monitoring in, you're going to get a nice red flag that something's gone wrong. But if you're creating a resilient app and you're kind of filtering out those bad data entries, unless you're logging that anywhere, then you're going to end up, just the app will work, but you're not surfacing the data. So a concrete example of that is, imagine we're running a shop and there's 10 items in our shopping list, but if 2 of those are not formed correctly, so imagine they didn't have a price, the app will not render those two items, but it won't crash. So the app will look like it's working and the end user will probably think it's still working, but actually there's two items that are not being rendered there. So it's kind of how do we kind of escalate some of those issues?
Okay, that makes a lot of sense. I think especially if you're working with a different team, like they could just change their stuff and your stuff breaks because, like, hey, we need a price to display this and it's not there. So how does the stuff that you put in place fix that problem?
So it depends on what level you kind of deploy it. So if you could get your so there's kind of proactive and there's kind of reactive style of doing this. So the reactive one is probably the simplest. We can deploy our code into I don't know, some kind of cron job or something that will just scrape the web service and just continually check that it can parse the data down. And if it can't, then it would maybe ping off an email to someone to say we're unable to parse this data now. But then the proactive monitoring would be, or the proactive approach would be, if we can get this component, the kind of production code put inside the upstream team's continuous integration pipeline, then we can make their builds fail if they're going to break downstream clients, if that makes sense.
Okay, so you're in a company, you've got a different team that handles the services, and you're actually creating code that's going to be part of their CI pipeline. And you're going to say, hey, this is what we need from your service. This is the contract. If this breaks, we can't use it. And you're actually putting it in their CI pipeline. So it breaks their build if they break something.
Yeah, so that's definitely, so that's one way of doing it. Another way, you could be slightly less active and they could call out to your tool and they could just flag. So it may not prevent them from actually building. And then obviously these are problems you don't really want to have, but this is often where you end up with in bigger companies. In an ideal world, you'd literally be sat on a desk opposite or next to the web team, or the team providing these services, and you'd be able to just have the conversation in the first place. So this is kind of when stuff's broken down a little bit, and you're trying to salvage what you can, I guess.
No, that makes sense. If you're working with a small team, like you might be working right next to the back end engineer. But in a bigger team, like the other team could be literally anywhere in the world. So you don't really have day-to-day contact. They might be asleep. They might be in a completely different time zone than you. With the thoughts that you've written about in your blog post, how can we organize our code so we can build tools like this?
So I think the kind of most obvious things for client developers is to not import kind of UI kit is probably the biggest thing. It's keeping our imports minimal. So as soon as you import something like UI kit, that means you can't deploy it to Linux anymore. And that's really helpful if you want to build some of these toolings that you can deploy anywhere. So it's really keeping an eye on what you're importing. If it's available through Swift Package Manager, then you're probably okay. And then I guess it's just it's using modules to create the proper boundaries, I guess. So you shouldn't be aiming to have nice layers of code that aren't just big balls of mud, really. So it's where people have been going anyway. So modularization has been pretty popular recently. Some of it's to do with getting compile time down. Some of it's to do with getting clean boundaries between the different responsibilities within your app. And I guess this just plays to that. If you've got your networking client nicely separated from your business rules, you've got the choice of, do I want to put the networking client in a separate app and deploy that? Or you can even build it up and say, actually, I'll build a separate tool that has the networking client and the business rules, because that's probably important for that particular tool to see, not only going through the network, but also applying some of the business rules.
Okay. Can you walk through like an example of kind of abstracted networking client with business rules? Like how would that work in either in a CI system, or you're self-hosting like a server that's for testing?
Sure. So I think in the blog post, there is a GitHub repo that accompanies it, and there's essentially a shared folder, and that's containing that's just a really simple client. That's just, in this particular example, it's interacting with a JSON placeholder website, and that's literally just wrapping up the kind of network request. And then I guess that would probably be one module. And then if you wanted to add some business rules to this, you might then create a separate module that would import that networking client, and that might apply some kind of filtering or whatever business rules you want. And you can then take those two pieces together as the kind of bigger package that manages your business rules and your networking to interact with that service. So in the blog post, I've kind of taken this shared kind of module and placed it once within a command line application, which is just give it I believe it was just a single command, and all that's going to do is spin up a dispatch main loop and run the network request and then exit. And then the other use case is it's just been imported into a Vapor web app. And in the Vapor example here, it's essentially this is for, imagine if you're an on-call engineer. So if you're supporting your app and you get called out at, I don't know, 11 o'clock at night, it'd be really useful if you don't have to fire up the application itself in the first instance. What you might be able to do is just go to a website that's using the exact same production code under the hood. And in the example, what it actually shows you is on the left, it shows you the raw JSON. And on the right-hand side, it shows you the kind of parsed JSON. And you can see what the application understood and what it didn't. And then above both of those, it's kind of showing the errors that were actually raised during the JSON decoder process. So if you as an on-call engineer, without actually firing up the app, logging in, trying to reproduce stuff, you can just navigate to a website and then get, some useful diagnostic information about, this didn't pass this information because it's missing this particular key. So these are all kind of things that I imagine would be super useful if you're ever getting called out at 11 o'clock at night. So that's kind of a high level run through of how you'd modularize it to get this kind of multiple use case.
That's pretty neat. Question I have though is where does this structure, this design pattern kind of break down? What are the restrictions or the fallacies of this design?
So maybe this is a case where I've not run up against it yet, but not really seen any kind of real disadvantages, because this all stemmed from problems I've had in the past where we had a single application that was, just one binary, essentially, one blob of code, one target, and it was impossible to debug stuff. And in the past, what I've then done, if I need to interact with a networking client, is I've probably written a separate tool in Ruby. And the problems you're going to get there are that actually it doesn't matter how hard you try, you're using different runtimes, different stacks. So there's no guarantee that you're going to be doing stuff the same way. So those are the kind of problems that we're trying to overcome. And then actually organizing code in this way, I think you can, it's like any new technique, you can go too far. So you can end up creating hundreds of modules, and then you probably end up in the node world. But if you if you're drawing your boundaries sensibly and you're keeping track of the architecture as you go, it's probably not that bad. I think it's one of those things where if you sat down and said, right, I'm going to draw the architecture of my app before you start, you're in for a bad time. What you kind of need to do is evolve these things as you go, and you'll find that you did make some modules really well, and you'll find that some of them you need to, redraw the lines because you've either got it wrong or there's maybe a new abstraction to add in there. So I've not come up against it yet, but maybe I have. But the friction I've felt is just, okay, we need to just change this boundary slightly, rather than, this whole process is not going to work anymore.
Right. Well, so one of the things that I'm thinking of specifically would be you've got cross-platform code here that is expected to run on an iOS platform, command line interface platform, and then a web platform. And the web platform, in my mind, is like an always connected, always online platform, whereas a command line interface or even an app has the potential for being offline, and could possibly break down this structure. I guess in that case, like you said, you'd probably put in some extra code that handles those situations that might throw errors or display information to the user indicating that they're offline and they won't have full functionality, right?
Yeah, so I guess it depends on the use case. So the kind of the things I have been using this for at the moment, for kind of for putting things in CI pipelines or monitoring or this kind of on-call support tooling, these have all really been acting as just proxies. So it's just hitting the back-end service, but through our kind of production code in the middle. So that inevitably can be quite stateless as well. So in the example, I've done a kind of Vapor web app, but there's nothing inherently stateful about that. There's no database or any caching. It's literally just calling out. And yeah, in some cases, you're going to want some state, and maybe that's where this would break down. But I guess in the use cases I've had so far, where we're essentially just acting as a proxy, this has all been fine to kind of remain stateless and just always execute those network requests as a kind of a one-off deal, I guess.
Okay, that makes a lot of sense. So I'm trying to envision how, like, I'm going to write my network client, with maybe some business rules. So if I'm writing my client, there's going to be three things that are using it. We got the iOS app. We've got a command line tool that someone can just come in and write a command line tools for a test, and we've also got the Vapor, a Vapor app, a web app. How do we write code that will work for all three of those platforms?
Yeah. So the way in my example is I've essentially I've gone for network requests that have a kind of a closure callback. So that's a fairly natural pattern on iOS itself to just have a closure off the end of a network request. And then in a command line interface, that means because it's asynchronous, you just need to spin up a kind of a run loop. So at the bottom of my kind of main file, I'm calling dispatch main. And then when I get to the end of my network request or going through the asynchronous business rules, whenever I've finished that process, I just call exit with, either exit failure or exit success. And that kind of allows you to have this kind of asynchronous code running in something that's normally fairly synchronous. And then in the Vapor world, it's probably the same for any kind of web framework. It's just taking the exact same again, the kind of completion handler based callback, but converting it to futures. So there's actually a fairly simple way to do that. You get it from the request. You create a promise or a future. I can't remember the exact syntax now, but you create a future, and then basically you're going to call it into the networking client. That will go do its asynchronous work, and then in the completion handler, you just resolve the future, and then that's kind of how you get that across all three platforms.
Okay, let's dive in a little bit into like the command line approach, because as you mentioned, if you just fired off a command line and fired off a network request, your command line is going to get to the end of the code and exits, and the request comes back sometime later. Can you talk a little bit about the run loop that you said? How to set that up?
Sure. So I think in the actual example project I've got, essentially all I'm doing is I'm making a copy of my networking client and then performing the request I want, which is just fetching any data, I guess. But at the very end of my main.swift file, I just called the kind of top level function dispatch main, and that's what will kind of kick things off. I believe that's the function that gets called in when you call the UI kit main. I think that's the thing that's kicking off the run loops, etc. I'm probably completely wrong on that, but yeah. And then to basically, so that's now you've got the command line basically sitting there waiting for you to actually do something. And then when your network request finishes and comes back, that's when in the kind of completion handler, I just call exit and then give it some kind of exit status. And there's a couple of constants, one for exit success and one for exit failure. So that's kind of how you get in your kind of synchronous command line interface to execute asynchronous code for you.
Okay. Another problem I ran into while hacking on like command line stuff is like I would write a command line, some stuff. It worked great on Mac. I ran on Linux and it was missing something. How do you avoid code that's not going to run, that's not implemented yet in Linux?
So this one's a little bit more painful. This is where you just kind of, if you can get some kind of, if it's an open source project, then most kind of CI vendors will potentially give you some free resource. So you can, at that point, you could just be, kicking off some kind of continuous integration process that will run it on Linux. Other than that, I think it's the kind of same thing I try and do for most kind of projects is I make it as simple as possible to run the different environments. So for this, for example, I might create like a .serve or just a little helper, which would essentially, Dockerize the app, and while it's doing the Dockerization, it will kind of pull in all the dependencies it needs and then start to build it, and then it will probably fail at that point. So I don't know if there's a foolproof way of doing it, but just trying to get it to run as often as you possibly can in an automated fashion is probably going to get your most bang for your buck there.
Okay, this sounds like a good justification to write unit tests for all this code, because it's going to get exercised every time you deploy on Linux.
Yeah, I can support that.
Yeah, certainly. I think the beauty with these things, with modularization, if you're getting the boundaries right, then you should be able to get some pretty nicely unit testable code. Keeping in mind that we're immediately saying we're trying to avoid importing UI kit or any kind of UI. That means some of the kind of obvious excuses of it's really hard to test UI stuff goes away. And it means that you can actually focus on if this is all kind of just model level code or controller code, we should be able to kind of get our dependency injection straight and make this stuff fairly testable. So that's kind of this. I think this is where I enjoy a lot of this kind of more frameworky type code, because it is a lot easier to test than some of the UI based code.
Yeah, I can attest to that, and I found that in my own solutions as well. That breaking things up, modularizing, and encapsulating does make things a lot more testable. Another question I have is what kind of libraries, third-party libraries that you would bring in using the package manager, Swift package manager. What have you found some good ones that you could recommend? Like, for instance, I know Alamo Fire is a really popular networking library that a lot of people use. It seems like it would work for all three of these platforms, and so that would be one that you could pull in and use. Is that correct?
So Alamo Fire, I'm not 100% sure. So it's one of those ones where I think a lot of the stuff I've done recently, I've tried to do as dependency free as possible. Not because I like to reinvent the wheel, but just because the kind of core frameworks have been getting better all the time. So Alamo Fire, for example, I think I'd probably just jump straight to URL session these days. But then there are some of the libraries that I do like when I was looking at the Vapor side of things, I'm not particularly fond of the kind of templating libraries. So immediately, because I don't do web enough, I just kept hitting issues, and you'd only find out about it when you're hitting refresh in the browser, which is cool that you can do that. You can just refresh in the browser and it's kind of executing your template. But I kind of want to be more compile time safety. So that's where I think I've started looking into stuff like the point free library for HTML. But in terms of Swift packages, I think I've tried to keep quite light. So one of the use cases I did have for a project recently was I was using RN Crypter, and that's a nice, easy one to pull in. I can't remember if we actually. I can't remember if I actually tried that on Linux. I don't think it would. Not sure if it would work. So again, yeah, it's probably another case for just, you can certainly try these things. Just make sure you've got some kind of CI setup or a really simple way to run your code and get it to attempt to run inside Docker to find out these compatibility issues nice and early. Right,
and yeah, find out quickly and early whether they work or not. Also, what about local data storage? Like an SQL database would probably work for all three of these for these platforms as well, right? Is that what you would recommend?
So I think this is where my approach might be to create an abstraction layer, I guess. So because it might make sense to use a particular vendor for SQL on the Vapor side. So I believe it supports like Postgres and MySQL. Whereas if you're going to go to a native client, you might want to jump on core data or whatever wrapper. So you're probably better off creating an abstraction above that you can then just create little shims to go to the different kind of back-end providers on the different platforms. I think that's the approach I probably go for these days.
That makes sense.
So I'm if someone proposed this to me, like creating abstraction over the database layer, that would immediately worry me of like we're creating too much abstraction. Do you have examples of like this working well, like hiding the core data away, so it could be Postgres or core data or whatever under the hood? Does that work well?
I think as a counterexample, I think so I've definitely seen it work poorly where I've worked on core data apps before, and some of the problems have been of my own making, that actually it's very easy for the implementation details to leak all throughout the app. So I've been bitten by that in the past, and I think that's where I would probably be looking to move the abstraction away so that actually it can be using the full power of core data under the hood, but I probably don't need to know that from the client side. I think so something we did recently that worked out really well was essentially we didn't need to know about any kind of relational database type stuff. So we built a kind of abstraction, and it was essentially like a key value abstraction. So it looked a bit like a dictionary from the outside, but it had the ability to write to a plist, or if you wanted to write to core data, you could, and you could fully map it out into a relational database. Or the other use case was to kind of write out as a directory structure. So, the key would be like the file name and the contents would be the value. So those were kind of used within one app, and it was kind of, they were just called storage strategies. So in some cases it made sense to have your data in a plist because you're only going to have like, a handful of keys. But in other cases we'd have hundreds of records. So you don't want to be, storing a plist with hundreds of records each time. So that would be where we'd potentially dump it out to disk as either a core data backend or just a flat file store. So I think that's just something that has worked quite well. And again, it's there's no silver bullets here, so you're not going to necessarily jump to that abstraction every time, but all depends on if that kind of makes sense for what you're doing at the time.
Okay, that makes sense. So you have a dictionary type object that can write itself into any number of formats, the core data file system, and probably rehydrate itself. And one thing I have done to abstract away core data from the rest of the app is, you've got your NS Magic object, and I've done ways of making just a clean Swift struct out of that, the data, for a case where you're not really modifying it, you just need to show it. So I've made a method to just create a clean struct. So you can create a new view or whatever without any core data NS Magic object oddness. So that's one thing that's worked for me.
Yeah,
go ahead.
So yeah, I've definitely seen that work really well, and I think that's kind of in one of the apps I was working on. They had Realm, which kind of tries to act a bit like a normal object with some behavior tacked on, but again the abstraction leaked away. But I think that general idea of convert to these really simple representations as soon as possible is really cool. And then I think taking that idea further, what we've kind of often done with the kind of interface segregation principle, trying to keep things small. If you've got this big object that maybe it represents a product within a shop, if you're going to pass that down to a view that doesn't need a whole product, then sometimes if that's going across the boundary, sometimes it makes sense to wrap that up into a smaller kind of view model and just chuck that over rather than chucking the whole object, because that can easily lead to situations where people start trying to grab data they probably shouldn't have access to, or they can accidentally grab the wrong kind of value from that object. So if you kind of neuter it down to just the core properties it needs, then it makes things slightly more foolproof at the end.
I was just going to say that I agree with that approach, and I've even done that myself, where I've I've converted objects once they came out of the database into the simplistic or the pared down items of what I need, and also to pull those and not couple them to the database and the format and the structure that the database expects them to be in. I did this with Realm, actually, in fact, where I encapsulated all of the interaction with Realm all into a database class, so that all the interactions that happened with the information that needed to go to or from the database happened through that class. And so it was all encapsulated. So if some point in the future we no longer wanted to use Realm, it was just a matter of changing that one class, rewriting that one class, my database class, so that all the information coming to and from could still use that class, but under the hood it was rewritten to use a different database other than Realm, and it could be swapped out for core data or any of those other solutions that you choose.
Yeah, I think that's you mentioned it there about having different representations. I think that's a really powerful technique that we can very easily forget. So I've definitely seen horror stories where people have taken the data they get from the network feed and literally just mapped that one-to-one within their applications. And then these monolithic data objects that were probably designed to be served on a website somewhere are now floating around about a whole kind of application. Whereas what we've done on different apps that's worked really well is we take the kind of the data from the network and we literally just map it into our own representation that we're going to use throughout the whole app, almost creating our own kind of foundation types. And those become the kind of the common language used throughout the app. And then that means that if the back end changes, all we need to do now is just, get the feed from a new back end, map it to this common representation that we kind of agreed on. And yeah, I think that's a really powerful technique to just say our actual app is not dependent on the back end or on a database. Those are just ways of storing data. Throughout the rest of the app, we'll work with much simpler representations.
No, that makes a lot of sense. That way, what you're getting from the service, how it comes down through the network or whatever format, is an implementation detail. So if the server changes, like, you can modify it in one place and not blow everything up in your app.
Sure.
So I feel a pick coming on, based on what we've been talking. But is there anything that we should cover anything else we want to cover before we get to the picks?
Nothing from me.
Okay. Any last questions? Sounds like a resounding silence. So, yeah, let's get to the picks. Michael, what do you have for us?
All right. So my pick for the week would be, I guess, a little shameless plug for myself here, that I recently published a GitHub repo on an example of how you can use MVVM with coordinators and integrate that into Swift UI. Because I was having it was just a personal challenge I was experiencing, where the Swift UI seems to be driving people towards the MVVM structure, but coupling those view models and view controllers, or in Swift UI, they're called views. They're coupling them all together, especially when you're using navigation controllers. So for instance, the navigation view, inside of that, when you specify a navigation button, it requires you to specify the view that it is going to be going to when the user clicks on the navigation button. And so when you have coordinators, it's also, I've heard them called routers, where you have an abstraction above that kind of controls the flow of your app, that doesn't really allow that navigation button doesn't allow you to specify what view you're going to from an external source, like what a coordinator is supposed to do. A coordinator its job would be to specify what view is to be the next view in the stack after a user clicks a navigation button. And so I wrote a repo that kind of hacks the navigation button in order to demonstrate how you can push that control back up to the coordinator to let the coordinator determine what view is to go next. And so it's a little hacky, and hopefully Swift UI 2.0 or the next version will be a little bit more supportive of that structure. But for now, I've come up with an example of how you can get away with it. So I'll publish a link to it in the comments.
That sounds pretty cool. We've had, so the coordinator pattern is something that described, or at least introduced to the iOS world by Suresh Conley, who's been on the show. I don't think we've ever talked about the pattern itself, but that sounds like a cool episode to even talk about this product and how it works, or talk about the coordinator pattern and how it works with SwiftUI. That would be a cool thing to talk about. Just throwing that out there. I'm going to do one pick, and my pick is based on what we discussed briefly. Have either of you gentlemen read the book Domain Driven Design?
I have not.
Okay.
I haven't, but I've heard the term.
Okay. A lot of the concept that we got into, I was at least introduced to through that book. It's been around for quite a while. I'm not sure when it was actually written. I read it when I was doing more back-end work versus native stuff, but a lot of the concepts that I've learned that I think a lot of the iOS community has not caught up with are contained in domain-driven design. And I was thinking about this book recently because Veronica Ray, who's been on the show before, tweeted out, hey, what are some books that have really helped senior lead staff type engineers really level up their design skills? And this is one for me. So what I think some of you talked about of taking a complex data model and just extracting like a small piece off of it. That's something I picked up from domain-driven design. So I'm just going to make that pick. And there's a small version that's online. When I first looked at it, I thought the domain-driven design quickly PDF was like $30. Turns out that's free, but you can buy a print version if you want. Most of what you need is going to be in the quickly PDF. I ended up buying the book afterwards, and there was some cool stuff in there, but almost no one's read the entire book. It's pretty long. I'm not sure all of it translates well, but the concepts are very solid. And if you're looking to level up your kind of design and architecture skills, especially in mobile development, this is good because a lot of the concepts are some very, they translate very well to mobile development. So domain-driven design is my pick, and we'll drop these in the show notes so you can look them up. Our listeners can look them up. Paul, do you have a pick for us?
I'm feeling under pressure there because those are two very good picks. So I guess my pick is it's a 2012 talk by Gary Bernhardt called Boundaries. My colleagues probably hate me because I mention this nearly every week because it's a really good talk. I don't know if anyone's seen Gary do a talk before, but his talks are very polished, and he's got a very polished podcast where he goes through some pretty cool stuff. And this Boundaries talk is kind of it's about building these kind of modular units around the idea of a functional core imperative shell. So I know that kind of got a little bit of attention a few months back in the iOS community. So this is just a really good kind of reference talk, brilliant speaker. And it's kind of, now that we got Swift and we can bring a lot more kind of functional concepts in, the kind of high level idea, I guess, is building these small functional cores that are really well tested. And then you just put the kind of imperative code, your networking, your disk access, all the ugly stuff around the outside of these kind of cores. And then you essentially build up loads of these little units, I guess. So kind of ties into some of the kind of thinking I've been doing a lot recently with modularization and how do you build these kind of nice boundaries between your kind of responsibilities. So that's my pick. Okay, very cool. I believe I've seen that talk. I haven't heard much talk about it in the mobile community, so it's cool to hear some that's had some influence here. Do you have any blog posts that cover those type of concepts? I can try dig them out. It was quite a while back now, but yeah, I'm sure there was a spate of 2 or 3 of them. So I'll try and dig them out and get them sent over.
Okay. Awesome. Well, if our listeners want to get a hold of you, Paul, how can they find you?
I am on Twitter at Paulio87. I generally just literally announce blog posts that I've written. So, but yeah, if anyone gets in contact, then I'll be sure to respond.
Very cool. So thanks a lot for coming on the show. I gained a new perspective of what you could do with cross-platform, Swift development, how you can use it to do CI and testing. So I thought that was some cool stuff. So thanks for coming on the show.
Thanks for having me.
All right. For everyone else, we'll see you next week.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit